Guys, so basically in today's POTD we have a problem. Remove loop in linked list, and basically it is a medium of problem. And the problem statement is like given the head of a linked list that may contain a loop. A loop means that the last node of the linked list is connected back to a node in the same list. The list is to remove the node. The task is to remove the loop from the linked list if it exists. And the custom input is given here. Head of a single linked list and a position which is like one base index which denotes the position of the node to which the last node points to. If position is like equal to 0, that means the last node points to null, indicating there is no loop. And here it is, one more statement is given here. The generated output will be true if there is no loop in list and other nodes in the list remain unchanged, otherwise false. Okay, so basically this problem is like related to the yesterday problem as well as the day before yesterday problem. Like we have discussed, like in the day before yesterday problem, there the problem in that problem we need to check that whether the single list is like having any loop formations or not, and we have like learned how we can check that whether a single list is like having loop have inside like having loop or not inside any linked list. So that things we have like discussed in the day before yesterday problem. Okay, and in the yesterday's problem again the similar type of problems like there we have check whether the linked list is like having loop or not. If there is loop, then we need to return that node where, or we consider that positions where the loop is actually started. Okay, but here we need to like remove those nodes from where the loop is formed. Okay, so it is also like similar problem. Like if I'm talking about the example one here, and we know very well from the last 3 days, that means the day before yesterday problem, the yesterday problem, and the today's problem. This all the loop, this all linked list problems are like based on one based index. Okay, that means they're starting from index one, and here it is saying that like if I'm talking about this particular example here, so here head is like given as 134 and position is given as 2. That means after this node is like connecting to the position 2 node. Okay, like this position 1, this is position 2, this is position 3, and here the statement is like clearly said it here that if position is equal to 0, it means the last node points to null. That means there is no any other element is like connected to the last node. That means there is no loop. Okay, and if this position like which is like greater than 0, that means it is like connected to some position like here position is like 2, so that means it is connected to the second node of the linked list. Okay, so it is like forming the loop. And in the second example, like after 4 there is no and here position is like also 0, that means after 4 there is no any loop formation, so it is not having a loop, so here we have to return true. Okay, and similarly if we're talking about this thing 1 2 3 4 and here positions like 1, that means here it is also creating we can say that a loop from the position 1. So here our task will just simply remove those nodes from where the loop from is actually going to be formed. Okay, so this is like also a very much important question as it is like also asked in VMware, Morgan Stanley, Amazon, Microsoft, Snapdeal, MakeMyTrip, Oracle, Walmart, Goldman Sachs, Adobe, Qualcomm, Colgy, and Netscope. And the topic talking about topic text, so it is like also based on linked list 2.0 data structures and algorithms. Okay, and related articles like this thing, and related interviews are like this thing. Talking about time complexity and space complexity. So the time complexity will like order of man, which is basically done by using like we have to traverse it, and we need to check whether it will like forming a loop or not. So for that, it's make the time complexity as order of one. And talking about auxiliary space, that means order of one. That means we don't have to use any extra space. Okay, so let's try to solve this problem with a particular step. So for solving this problem, our first step, which we already know, that means here first we check whether the list is having any loop or not. Okay, so let's try to check it. We know very well we have to solve this problem by using two pointers. So first of all, we have to create a node star fast, which I have to point it on the head node. That means in the initial stages, we have to like uh, initialize two pointers, declare two pointers, and initialize with head node. Okay, so a node star slow is equal to head node. In the initial stages, both the pointers like fast node and head node, fast node and slow node, both are like pointing to head node. Okay, now then after that we need to traverse it and check whether there any loop formation is like present or not. Okay, so while fast and fast next, okay, we have to check with the help of fast node whether the loop is like present inside the linked list or not. Okay, so let's try to check it. So here we have to define their functionality. That means fast is like moving by two step. That means fast next. Okay, fast is moving by 2x speed, and slow is like moving by one step. Okay, these all are things which we have like done the day before yesterday. Okay, so yeah, then after that we have like checking the condition there. That means if fast node is like equal to slow node, that means yeah, there is any loop which is present inside the linked list. And these things we have like done the day before yesterday. So there we have to like simply return true. That means yeah, this is like making a formations of loop. But here we don't have to return anything as it is like void data types. So here we have to like simply remove those nodes. So yeah, we have getting the idea that yeah, here the loop is actually created. So for those only, what we have to do here, we are going to do let's say first of all we have to define slow, which I have to point it on head node. Like after performing this thing, now we get an idea that yeah, there is a loop in list. Okay, so if there's a loop in the list, then again we have to point our slow node towards head node. That means again we have to start it from the starting position, and we need to check it for the for those nodes from where the loop is actually going to form. Okay, these problems we have like done yesterday to get the those node from where the loop is actually formed. But in yesterday's problem, we have to return those nodes. Here we have to remove those nodes. Okay, so for that, all the processes like same. Here we have defined like slow node as head node because we are going to like check it here, and again we are going to traverse it here. Like while my fast node is like not equal to slow node, there we have like done the same thing, and here we have to like move by one steps, both of them, both of the pointers we can see that means fast is also like moving by one step, and the slow is like also moving by next step. Okay, fast is equal to fast next, and like slow is also moving by slow is next. Okay, and thereafter that while traversing these things, there like in the study form we have like simply return fast. Okay, that means this will return the this will return those nodes from where the loop is actually formed. But here we have to also check it for the first next condition. Okay, so again here we are going to give the another condition. That means if fast next is like not equal to slow, then also for that we have to like do this thing. That means fast is equal to fast next. Okay, and then after that here we have to do what? Here we have to do fast next. That means those node. Okay, whether either it will like fast node or the fast next node, we have to make it as null. Okay, so let's try to compile and run, as we don't have to return anything here. Okay, so here it is throwing an error which is like fast next is not equal to. Okay, so yeah, here. Okay, let's again try to compile and run, and here what it is showing that compilation error. So I think here fast is equal to fast next, and it will be like fast is equal to fast next. So next, yeah, if I'm talking about if fast is like equal to, so that means yeah, it is like loop. Then after that we have to write it here. Like first of all we have declared like slow is head. Then after that while fast is not equal to slow. Then we have like move fast is equal to fast next and slow is equal to slow next. And then okay, so here we don't have to return anything. Okay, that's the mistake here which I have done. Let's try to compile and run again. Okay, again 10-minute exit problem fast. Okay, so again I don't have to like use this thing. We have to just simply perform for fast is equal to fast next. Okay, that's the silly mistake which I have done here. Now let's try to compile and run again. Yeah, now in this time it is our compilation is completed. Let's try to submit it. So it's submitted. So that's all for today. Thanks for watching.